Hello everybody! This is evaluating the effect of timeline shape on visualization task performance. My name is Sara di Bartolomeo, and in this presentation I am going to talk to you about timeline shapes. We all know that timelines come in many shapes and forms. When we think about a timeline, this may be the first thing that comes to our mind, a straight horizontal line. In this representation, events are shown as colored dots on the line. We know, though, that this is not the only way to represent a sequence of events. We could use a line, or we could use a circle, a spiral, or any other shape, and they would still convey how one event follows another. And perhaps some shapes would even work better for certain tasks and certain characteristics that the temporal dataset can have. So let's consider the properties of the data that we want to represent. A dataset containing sequences of events can have events that never repeat throughout the dataset, events that repeat, or a mix of the two. We call these groups non-recurrent, recurrent, and mixed. An example of non-recurrent dataset could be a historical timeline in which each event has a date and they do not repeat throughout history. An example of a recurrent dataset is the planting schedule for a farmer. Each plant has a specific time frame in which it needs to be planted, and it reoccurs at about the same time every year. Here, in the representation below, dashed lines represent repetitions, and events of the same type are represented with the same color. You can already see a possible benefit of using different shapes. The spiral can have repeating events be aligned, and the circle can be divided in equal parts, for example. Mixed datasets contain a mix of repeating and non-repeating events. An example of this is the daily schedule of a person. It can have repeating events, like classes or weekly recurring meetings, and non-repeating events, such as parties or one-time meetings. In the representation, repetition is still highlighted with a dashed line, but there are additional events that do not repeat throughout the dataset. So the question that we asked ourselves at this point is, what timeline shape is best to represent each dataset? Here is a representation with all the dataset types and all the possible shapes that we considered. One could intuitively guess that the best timeline for a non-recurrent dataset could be a line, for example. A circle could be the best option for a recurrent dataset, while perhaps a spiral could do a good job representing a mixed dataset. In order to find out if this intuition was correct, we ran an experiment comparing all these different shapes combined with all these different data types. In order to test our theory, we first interviewed people who deal with timelines every day, a history professor and a researcher working with temporal events in personal health informatics. This helped us understand what people want to learn from timelines in different fields. So we decided to consider these four tasks. When, in which we want to figure out the date in which a specific event happened. One example of this would be, when did the earthquake happen? What, in which we want to figure out what event happened at a specific date. For example, what happened in 1999. Find, in which we know both the event and the date, and we want to find the location on the timeline. For example, the earthquake happened in 1898. Find it on the timeline. And finally, compare, in which we want to know the timing of an event relative to another one. For example, did Cleopatra live closer to the launch of the first iPhone or to the construction of the pyramids? And by the way, Cleopatra lived about 2,500 years after the construction of the pyramids, and 2,037 years before the launch of the first iPhone. So yes, surprisingly, Cleopatra lived closer to the launch of the first iPhone. We then created three datasets, as mentioned before, a historical one for the non-recurrent category, a planting schedule for the recurrent category, and a person schedule for the mixed one. By making up the datasets, we made sure the participants in our experiment would not have any previous knowledge about the data that they would be seeing. This picture shows our initial designs that we would use in our tests. Unfortunately, we soon found out that these colorful designs would introduce additional variables into the experiment, such as colors or the orientation of the text, that could influence our results, while instead we just wanted to see the effect of the shape. Therefore, we ended up ditching all of that and trying to achieve a design that would be as plain and simple as possible. We also had to balance the number of data points to be shown in order to be clearly readable on many different screen sizes. We finally decided to settle for 12 data points on every timeline, and all the text had to be horizontal and there would be no time spans, and the text would use a plain Arial font. Our horizontal timeline ended up looking like this. The data and tasks we ended up using, as well as the designs, are extremely simple. We argue that to fully understand the effect of the shape on speed and accuracy, we must start from the simplest datasets and tasks. Another reason behind the simplicity is that timelines are extremely widespread. Since almost everybody encounters timelines daily, simple static visualizations play a valued role in communication. Before pre-registering our experiment and analysis, we decided that using Mechanical Turk to recruit participants was our best option, as our target population was vast and very diverse, and Mechanical Turk would allow us to reach a very large audience. We gave each participant a set of 12 counterbalanced questions, every time changing the dataset and the shape of the timeline we were showing them, so that they would observe each dataset type with each shape. So, what did we learn? What we ended up finding out is that there is no overall winner, and no timeline is better than the others in every category. Some timelines work better than others in specific cases, while in some other cases, the choice of shape doesn't make any difference. In terms of timing, in the when task, where participants were asked to find out the date in which a specific event happened, with a mixed dataset, the choice of shape doesn't influence the results. With the recurrent dataset instead, spiral proved to be the slowest shape overall. In the what task, where users were asked to find an event based on a date, vertical timelines were the fastest for mixed and non-recurrent datasets. In the find task, where users were given a date and an event and were asked to click on it on the timeline, there wasn't much of a difference between the different shapes. The compare task, in which users were asked to compare two time spans, again showed that spirals were slowest, except for the mixed dataset, in which there was no difference between circle, horizontal line, and spiral. Regarding accuracy instead, we didn't find meaningful differences between the different shapes. Thus, we can't say that participants answered more precisely to questions on a shape rather than on another one. We just found out that the compare task, that was more memory intensive than the others, produced worse results. At the end of the experiment, participants could fill out an optional survey in which they were asked to express their preferences and opinions. In this chart, you can see the percentage of participants who selected each one of the shapes as easiest to read for each task. In most cases, horizontal line had the most preferences. Spirals and circles gain slightly more preferences on recurrent datasets, but are still less preferred than lines. From the survey, we received some interesting comments that pertained directly to the shape of the timelines. This gave us a notion of how the participants felt about certain shapes to an extent that they cared enough to express it in an optional feedback section. In this case, too, the majority of the comments were in favor of the horizontal and vertical lines. The comments were of similar trend. A few remarked in favor of the circular shape. The spiral shape also had a few admirers under its belt. However, on the flip side, some of these participants revealed concerns about the spiral shape, stating it to be difficult and confusing. Considering the findings of our experiment, we formulated some design recommendations for timelines using one of the dataset types we considered. Here is a list of recommendations regarding timeline readability. Use linear vertical timelines for situations which require fast data lookup. Avoid spiral timelines when the task requires fast lookup. If you use a more creative, expressive shape, such as a spiral timeline, also include a tutorial or visual cues to assist the user in learning and understanding. Regarding task performance, tasks which require long-term memory dependence, like the compare task, are slower and less accurate on all the timeline designs. This effect is amplified with spiral timelines. We recommend using linear timelines for difficult tasks which require complicated decision-making. And lastly, regarding dataset flexibility. Within this study, we did not find that dataset choice affects the readability of the timeline. Therefore, we recommend designers to be flexible with their choice of timeline shape to maximize readability or improve engagement. However, if the dataset is complex, even for mixed data, we recommend using a linear timeline. We want to stress that the importance of the following points, especially regarding timing, heavily depends on the context. For instance, in emergency medicine, a difference of a few seconds may be much more relevant than for reading a timeline published in a magazine. The one on the right, for example, represents the blood glucose values of a person with diabetes throughout a day. A medical professional may have to look through many of these charts in a span of a short amount of time. Therefore, this is a situation in which fast data lookup is relevant. It is also very important to keep in mind the expressiveness of the data, how well the timeline shape can represent the underlying data. For instance, representing linear data on a circular shape may be misleading to the readers by inducing them into thinking there are recurrences in the data when there are none. Here, for example, this type of spiral visualization on the right is widely used in schoolbooks to represent how long and complex the history of life on Earth has been before humankind. Here, the spiral is used to convey the sense that the more we go back in time, the more our knowledge becomes sparse. We therefore suggest designers carefully evaluate our recommendations based on their domain goals and specific use case. In the end, timeline visualizations are purposive in our everyday life. However, we know little about ways to design timelines effectively. In this work, we learned that the shape does indeed affect the readability of timelines. We found good evidence that lines support reading the timelines quicker than the nonlinear shapes. We also found evidence that spirals are not only perceived confusing by users, but are also slower in lookup tasks. We hope our work will encourage future research on the topic. So this is it. Thank you so much for listening. If you want to find out more, our paper, results and code are available on OSF.